Continuation of polynomials and the basic rules and behaviors. So polynomials, linear factors, and zeros. So key concepts: roots, zeros, x-intercepts, all mean the same thing. So if you have a polynomial, x minus b is going to be a linear factor of p of x. B is going to be a zero of the polynomial. B is also going to be a root or a solution to the polynomial equation, and B is also going to be an x-intercept of the graph. So if I ask you to solve, find the roots or solutions, set your polynomial equal to 0, factor, and set each term equal to 0 and solve for x. And here's what we mean. So writing a polynomial in factored form. We've already done this with quadratics in the last chapter. So here we're going to deal with polynomials. So we're going to deal with x to the third, x to the fourth, and still factor and still solve. So we just have to take an extra step and remember that when you factor, take out your GCF first. So for the first example, notice that your GCF is x. So you pull out your GCF, it's x, therefore we have x squared minus 2x minus 15. So factor. Now we have to factor again. So can you factor x squared minus 2x minus 15? You should be able to. Two numbers that multiply up to negative 15 and give you negative 2. You should realize by now that those two numbers are 3 and 5 with x and x. So we want negative 2, therefore this has to be negative 5 and plus 3. And there's the factored form. You can check your work by distributing and making sure you get x to the third minus 2x squared minus 15x, in which case you would. Here's another example. Again, always look for your GCF. GCF is x because x is in every term, therefore it's common and it's a common factor. So x comes out and subtract all your exponents by 1. We have to factor again. So we're just factoring, factoring, factoring. So two numbers that give us negative 1 and negative 12. So it's 4 and 3. Two numbers that multiply up to negative 12 and add up to negative 1. It's 4 and 3, negative, positive. Again, nothing new. You just have to remember to pull out your GCF first. Now, if we want to find the zeros of a polynomial function, you have to go back to the first slide, which says the zeros of a polynomial function is when each polynomial term is set equal to 0. So, zeros mean when are we going to have, when will y equal 0? So, when will y equal 0? When either x plus 2 equals 0, x minus 1 equals 0, or x minus 3 equals 0. So solving for x, x equals negative 2, x equals 1, x equals 3. So here are the zeros of the polynomial. Those are the zeros. That's when y will be 0. In other words, these are also your x-intercepts. Let's try it again. What are the zeros? That means when does y equal 0? So, when does y equal 0? It's when x equals 0, x minus 3 equals 0, and x plus 5 equal to 0. So x will equal 3, x will equal -5. And you got to remember that x equals 0 term. So here are your zeros, or your x-intercepts. Okay, mean the same thing. Next, writing a polynomial function from its zeros. So, if I give you the x-intercepts, how do you find the actual polynomial function? So we have to work backwards. So we know that the x-intercepts are -2, 2, 3. So that means x equals -2, x equals 2, x equals 3. So we got to work backwards. We have to set this equal to 0. So that means we have to add 2 to both sides. So we're going to have x plus 2 equal to 0. Here now we've got to subtract 2. So it's x minus 2 equals 0. Here we have to subtract 3, so it's x minus 3 equal to 0. Next we have to distribute these 3, because now we have x plus 2, x minus 2, x minus 3. Now we have to do distribution property. So x times x is x squared. X times -2 is -2. X. Then we have positive 2x and -4. Combine like terms. We have x squared. 2x's cancel out. -4. And you have to drop down the x minus 3. Distribute again. X squared times x is x to the third. X squared times 3 is x squared. -4x. Positive 12. And there is the polynomial function. I'll call it p of x with zeros -2, 2, and 3. I know it's correct because the degree will tell me how many solutions I will have. So degree 3 means 3 intercepts. And I have 3 intercepts. So you have multiplicity. What does multiplicity mean? It determines, well, it actually means how many times does a 0 show up. So if you have a solution that shows up twice, that's multiplicity 2. If you have a 0 that shows up 3 times, it's multiplicity 3, and so forth. So here, they want to know what the zeros are. So again, factor. So we have to factor this polynomial function. So I know that my GCF is x squared. So I'm pulling out an x squared. So I have x squared minus 2x minus 8. I'm going to factor again. So I need 2 numbers that multiply up to 4. -8, sorry. 2 numbers that multiply up to -8 and add up to -2. So it's 4 and 2. I need -2, so it's plus minus. And my zeros are going to be x squared equals 0, x plus 2 equals 0, x minus 4 equals 0. So here we have x equals 0, x equals -2, x equals 4. So here there are multiplicity 1 because they all appear once. and behavior is going to be linear. So in other words, one multiplicity, it's a linear behavior. If you have two multiplicity, it's a quadratic behavior. And if you have three multiplicity, it's a cubic behavior. To go further into behavior, I'll do one example. If you have zeros of -3, -3, 2, 1, those are the zeros. We have multiplicity 2 at -3. Here's 1 and 2. So that means at -3, we are quadratic-like. It's degree, so we have to have a U shape. Now, since we only have multiplicity 1 for these two, it's linear. So it's going to act, it's going to behave like a quadratic, and here it's going to behave like a line. So we're going up, and there's a line, and we go up. So you notice at -3, it's quadratic-like. And at 1 and 2, they're linear, so it's a straight line that goes straight through. I know it's quadratic down here, but you have to look at what it does exactly at the intercepts. If you have any questions, come see me, and we can do some more problems.